So what we want to look at now is what happens when we shine light on an atom. What happens to those electrons? And because we're looking at the Rydberg equation and looking at hydrogen atoms, that's what we're going to focus on here. And what I see is that I have different excitation wavelengths, so different amounts of energy that I'm putting into the sample. I'm going to start here with my longest wavelength because that's going to be the lowest energy. And I want you to notice two things. One, what happens to kind of our atom on how it looks, and also what happens to this electron that's at the n equals 1 level. So I'm going to click to send my photon of light. It travels down, comes in contact with my atom, and then that light is then emitted. And so if I send that again, I want you to look down here at the bottom. We have n equals 1, promoted to n equals 2, and relaxes back down to n equals 1. Now I'm going to go to the other extreme, which is our 97.3 nanometers, which is the shortest wavelength, so it's the highest energy. And I want you to see how things are different when I send this photon. So we release our energy source. We see we promote all the way up to n equals 4. We relax to n equals 3 with one photon of light. Then we relax all the way down to the n equals 1 with a second photon of light. And so this one actually has to relax in two steps because it's emitting light in two different wavelengths. And so what we'll see in different promotions to higher n levels is that sometimes we'll get an emission all the way back down to n equals 1. Sometimes there will be intermediate releases of energy, so we go from n equals 4 to 3 and then 3 to 1, for example. And that's going to depend on a variety of factors, primarily our incoming light and what the value of those wavelengths are.